right, so if we look at this graph, what are some of the things that we know are going to happen? So let's look at the vertical shift first. Patrick, vertical shift what? Okay, so we're going to take this point, we're going to move it up 1, 2, 3. Okay, so here's where our point is right now. Okay, so we took care of this. Now, what's the other shift that we see in there, Charlie? Good. So we're also going to move it to the left one, so it gets moved here as well. So that takes care of this portion. Okay, and then we have one last, or we have the 2. Again, you think of the absolute value of this. So the 2, is that going to shrink it or stretch it? So it's going to be a little more steep. It's going to be steeper than this original one. Okay, and then what does this negative on the outside do? So it's going to shift it up. So now, when we look at this, as far as our graph right now, so the reflection is going to move it down like this. And we're still going to shift it up. And so this, the way that this shifting occurs here is our horizontal asymptote is the key element that we want to sketch. So here's our original asymptote. If the vertical shift is up 3, where does this asymptote go? It goes 1, 2. It goes up 3. Okay, so it's easier to draw this first. So y equals 3 is the horizontal asymptote. Okay, now remember, if we took our original graph the way that we've shifted it, it looks like this, and it's steeper. But this whole thing is going to get reflected. That's where the negative goes. It's reflected across this x-axis. So this point gets moved down here. It's reflected across this asymptote. Okay, so I'm going to use a little bit thicker line here. So this point gets reflected across here. So it gets shifted, or it gets transformed to this spot. We're still going to have our graph approaching this asymptote, but it's going to get steeper, a little bit faster. And so this accounted for our horizontal shift and our vertical shift and our reflection. So this is what our graph is going to look like. As far as identifying key points for this, you need to be able to find the right elements on those. Okay, but this is what our sketch is going to look like. Right, so now when you look at this, and here's the questions that you're probably going to be asked on this. And this gave some of you problems on the square roots and cube roots. Okay, but you're going to be asked for to identify domain and range for these. Okay, in this particular case, are there any restrictions to the domain? The domain is what values of x you can plug in here. So is there any place where x's don't work? No. So the domain is all real numbers. So negative infinity to infinity. And what about the range? So what's the lowest possible y value of this graph? It extends all the way to, no, the lowest. It extends all the way to negative infinity. Okay, and then what's the highest point that it gets closer and closer to? That's our horizontal asymptote, 3. Does it ever reach 3? No, the nature of an asymptote is the graph approaches it but never reaches it. So will there be a bracket or parentheses at 3 for the range? So this is going to have a parentheses. And now the other way that you might see this asymptote identified is to use the same kind of explanations that I used right here. And so you might see something like this. As x gets closer to negative infinity, so if we go back to this problem, another form of a question that you might be asked is this. As x approaches negative infinity, what does f of x approach? What would our answer be? As x gets closer and closer to negative infinity, goes further and further this way, what does our y value get closer and closer to? Great. And so that's the other way that you might kind of be asked questions involving the range.